An account grows at a continuously compounded interest rate at 0.25% per year. What must the initial amount be for the account to reach $100,000 after 40 years? This uses the continuously compounded interest formula, which is the total amount is going to equal the principal times e to the RT. The principal is what you start out with. That's your initial. And I think that's a P-A-L-E or P-A-L, I don't know. E is the number E. R is rate as a decimal, and T is whatever time you're dealing with. Now, this is a simple matter of just saying, hey, let's plug stuff in and see what happens in 40 years. So my amount, no, it's not. Oh, I have to find out if I get 100,000. So you're A. Oh, this is much worse. So you're going to be A, you're going to be T. Now, if my rate is 0.25% per year, doesn't that mean that the R I care about is 0.0025? Yes, it is. So this is what I have to do. Okay. A is going to equal, I did it again. A is going to equal 100,000. So let's put 100,000 right there. 1, 2, 3, 4, 5 zeros. P is, I don't know, times E to the RT is going to be 0.0025 times 40. Now, this is a calculator problem, but I'm going to let Siri do all the work because I really don't want to jump to my TI-84 Plus. There's no need for me to do that because I'm not graphing anything or anything wacky like that. What I need to do is I need to find out what E to the 0.0025 times 40th power it gives me. So give me a sec, I'll be right back. That number ended up being 1.051, so 1.105, I mean 1.105, so 100,000 equals 1.105 P. And so we divide 1.105 from both sides, so let me go off to the side again and find out what 100,000 divided by 1.105 is. And that number ended up being 9497.74. So with a little bit of rounding, we're off by a penny. That's what happens when you do some rounding errors. But yeah, that's the number we got for the principal. So not pretty. That's how it's done.